Okay, so we left off having the Arduino blink the LED 10 times a second, and it's still doing that. And that's a good place, that's where we want to be. What we're going to do now is actually use some of the output pins on the Arduino, and we're going to use the solderless breadboard, and we're going to use some of the components to show you how you can actually have an off-board effector work with an Arduino. So I have the LED here. We need the LED. We also need the 220 ohm resistor, which is colored red, red, brown, 220. So that's 220 ohms. And the reason we need a resistor is because the output voltage of the Arduino is enough that it would eventually burn out the LED. So we're adding this resistor to restrict the flow of electricity through the LED so that there's not too much electricity going through it. We don't want it to burn out. The first thing we want to do is we want to connect a ground wire between the Arduino and the breadboard. And you can see that one of the pins, well, there's actually a few different pins that say ground, and you can use any one, but you'll see that one of the pins has a G and D on it. And the writing's quite small, so I'm putting glasses on to help me identify which pin it is. But you'll see one that says G and D. You plug that in, your jumper wire, into the ground pin, and then you plug the other end of the jumper wire into the blue rail. So what that means is now this entire blue rail on this side is ground, electrically ground. And anything you plug along that rail will be electrically grounded. And so that's a great way of now what you've done is effectively you've taken one pin and turned it into 30 pins that are all the same. Okay, so now what we want to do is we want to add the resistor to the solderless breadboard. And so the blinking LED there is actually connected to pin number 13 on the Arduino. You can see that there are pins numbered 0 through 13. These are digital pins. These are digital input and output pins that allow you to talk to the Arduino and the Arduino to talk to you. So what we're going to do is we're going to add this resistor to pin number 13, digital pin number 13, and then the other end we're going to put into J18 on the solderless breadboard. Okay, so we've got that done. We need to put the LED on still. And what we do with that is we put the short lead. Remember I said that there's a short lead and a long lead on an LED. The short always goes to negative and the long one always goes on to the positive. So we can put the short lead anywhere along the negative rail. Get a little closer to the resistor. And this is a good time to point out that you never want to accidentally have leads touch each other on the solderless breadboard, because then you'll just be shorting out the circuits. So make sure that you have clearance. But the other end of this, the positive lead, is going to go in the same row that the resistor went into, and I put it into H18. So now you see that we've got this blinking this LED is blinking at the same rate that the little LED down there is blinking, because they're both part of pin number 13. Now we can mess around with the time again and change this time on the sketch that we have. Right now it's blinking on and off 10 times a second. And we could go in there, we could change that to 50, we could change it to 1, we could change it to 1,000. Wouldn't it be neat if there was a better way to be able to change the rate of the blink of that LED than by just changing the program? Well, it turns out there is, and the answer lies in using this potentiometer to control the blink rate. And that is what we're going to do in the next video.